An introduction to and simplifying fractions with Adam Maths Tutor. Here are the beginner questions, some of the easiest questions that you're likely to find on this topic. We need to write which fraction of each diagram is shaded. Fractions are split into two parts and separated by a dividing line. The bottom part is called the denominator and tells us how many equal parts we're splitting or separating our diagram into. In this case, it would be 1, 2, 3, 4, 5, 6, 7, 8, and the top part of the fraction is called the numerator, and this is how many of those equal parts we have selected or shaded. So in this example, it would be 1, 2. So we have 2 over 8 or 2/8 of this diagram shaded. Fractions can be simplified, meaning if you have a common factor within the numerator and denominator, we can divide through by this factor to make the numbers smaller and therefore the fraction more simple than it was before. So in this first example, we can see that 2 and 8 are both in the 2 times table. That means that both of these will have a common factor of 2, meaning we are able to divide the top and bottom by 2 to give us a simplified fraction of 1 over 4 or 1/4. So for every 8 tiles we have, there are 2 that are selected or shaded, which would be the same as for every 4 tiles you have, 1 of them would be selected. For the next question, we have a diagram that's been split into 6 equal parts, and 1, 2, 3 of those are shaded, meaning our unsimplified fraction is 3 over 6. Both of these numbers are in the 3 times table, meaning they have a common factor of 3. So dividing through by 3 gives us 1 over 2, or 1/2. For the last question, we have a diagram that's been split into 8 equal parts, and 6 of those have been shaded. 6 and 8 both have a common factor of 2, meaning our simplified fraction would be 3 over 4, or 3/4. It's important to remember that fractions won't always tell you to simplify, but it's something that we must remember to always do. And lastly, when simplifying, it's always important you use the highest common factors to cancel and simplify down to the most simple numbers. For example, if I had 4 over 8, these both have a common factor of 2, meaning it can be simplified to 2 over 4, or 2/4. However, 2 and 4 both have a common factor of 2, meaning this can be simplified further to give you 1/2. You must always simplify as fully as you can. And for this example, if you spotted that you could have divided 4 and 8 by their highest common factor of 4 straight away, then that would have been the ideal situation. Alternatively, you can keep dividing until you reach the most simplified fraction. On to the intermediate question. With a slight increase in difficulty, use the fractions provided to shade the diagrams. On the left, we have a fraction of 3 over 4, or 3/4. This means for every 4 equal parts we have, 3 of them need to be shaded. The problem is this fraction has been simplified and we didn't start with 4 equal parts. We can go through and complete each bit separately. So for every 4 of these, we have 3 of them that are shaded. We can repeat this for the next column. So for these 4, we would have these 3 that were shaded. Repeating this for the rest of the diagram would result in this much of the shape being shaded. It doesn't matter how you've shaded your shape, just as long as at the end of the question you had shaded 15 of the squares, which makes sense as 3 multiplied by 5 gives us 15, and if we did the same to the denominator, that would give us 20, which was the number of original squares or equal parts we had. Going from 15 over 20 to 3 over 4 would be simplifying. Working backwards and multiplying is what we call finding equivalent fractions, as these two have different numbers but represent the same amount as a fraction. For the second question, for every 5 equal parts that we have, 4 of them are being shaded. We can repeat this for all of the rows and shade the diagram so it looks something like this. As long as you had 16 out of the 20 equal parts shaded, this would be correct. On to the advanced questions. Some of the more difficult questions that you're likely to find on this topic. Adam played 7 out of a possible 21 football matches. Write this as a fraction. so we can have worded problems as well as shaded diagrams. Remembering a fraction is made up of two parts split into the numerator and the denominator. The denominator makes up the amount of equal parts, which in this case would be the amount of football matches that were played, 21. And the numerator is made up of how many of those we're shading or selecting, which in this case would be 7. So the fraction of games that Adam played was 7 out of 21. Both of these numbers have a highest common factor of 7, meaning we can divide through and simplify to give us our final answer of 1 over 3, or 1/3. So Adam played 1/3 of the football matches. The second question, Adam sits a maths test at school. There are a total of 100 marks. He didn't do very well and scores 12. Write this amount as a fraction. Out of the total marks, which was 100, Adam scores 12. Both of these numbers have a common factor of 2, but we can do this a bit quicker if we recognise the highest common factor, which in this case would be 4, giving us a simplified fraction of 3 over 25. Here's a question that I've completed previously. It appears as though I've made some mistakes. See if you can pause the video, find them, and tell me what they are, or write some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.